Alright, I need 2 of your assignments for those of you that did not turn those in the Google Classroom. That would be 59 and 60. 59 was the book work and 60 was the practice quiz. So, if you did not put them in the Google Classroom, make sure your name's on each one and come turn it in the basket. You will also need a calculator for all of today's quiz, and I need your phones and smartwatches put up. So, go ahead and get all that stuff checked off, and when your desk is cleared off, I will bring you the quiz. Turn it off on the top of the front page, or all of the formulas I promise will be there. Just do make sure that you're being careful and copying them down and using them correctly. Like any other assessment, there would be partial credit, but I hate for you to lose a couple points just because you didn't copy the formula down from the front page correctly. And then a couple quick things to point out. Question 1 is asking you when you would use these, just as I told you it would be. But questions 2, 3, 4, 5, and 6, bless you, bless you. So 2 through 6 not only want you to get the answers, but specifically ask to see the formulas with the numbers plugged in. So basically, what are you putting in the calculator to get that answer? That's something you should be writing down for partial credit anyway, but based on those directions.
Do you have to write with the variables first?
I just need to see it with the numbers plugged in. So literally, whatever you put in the calculator is fine, but 2 points is set aside for that, and 1 or 2 points is set aside for the final answer. So I'm just saying, if somehow you were comfortable enough going straight from the formula to your calculator to the answer, make sure you're at least writing that down so you're not losing those points.
that, or do you want
Like that,
numbers?
that's fine, but you could just draw an arrow to that one.
Okay, sounds good.
Do I have to write in finding this? Or do I just write this in after I find this?
Show me where you're getting asked to.
So it's like on this one. Can I just find S and then just plug it into the formula, or do I have to actually write this as part of the formula when I write this?
Either way is fine.
Okay.
If it's not clear, I'll be flexible. There you go. You need to get these handouts in your phone too while you're. put that in, turn it back in. Okay, we need to move on here. So I did not verbalize this. I saw a lot of you guys that figured it out, but I do have two new handouts up here. So if you did not grab those when you came and got your phone, please come and get those. But we need to start looking ahead towards our next unit, which is over limits. And we're going to spend a few different weeks here. And today we're going to look at basically one question type, but also this question type will show you what a limit is, and that's what we're going to be working with and trying to find the next couple of weeks. So to start off, we're going to do limits when either given a graph or a table, which this is admittedly one of the easier ways to find the limit. You don't always have a table, you don't always have a graph, you don't always know what the function looks like, but when you do, then this is how you're going to approach this. Okay, so a limit question is going to be set up in one of three ways. There's three types of limits here. So, understanding this notation, this is saying the limit as x approaches, and then we put a number here, of some function. So as x approaches some number of the function, or the third option, as x approaches some number of the function. Now, of course, the function doesn't have to be f of x. The number that it approaches is going to just change depending on what it's talking about. But just for an example here, I'm going to use 3. As x gets close to 3, but what I need you to squeeze in for notes is sometimes there's a little minus sign next to the number it's approaching. This means from the left side. If there is a plus next to that number, that means from the right side. And if there's not a plus or a minus in the top right of the number, that means from both the left and right. Okay, so three different types of questions. Either what's the limit as x approaches the number from the left, the right, or from both the left and the right. So that one little symbol or lack of little symbol completely changes some of our answers. Now, what a limit is asking you to find is what y value is the function approaching at that x value. Not what is the y value there. It's not asking you for a point. You already learned how to deal with points a long time ago. Limits are asking what y value is it getting close to. Okay, so let's look at a couple of examples here, and then we'll answer question number 1. But we've got our function up here. What is the limit as x approaches 3 of f of x? This is f of x up here. So, to answer this, I need to know what the limit as, and you don't normally need to write this out, but write this out for the first one. I need to think about what the limit is from the left side. So here's where x is 3. This is what I'm focused in on. And if I'm focused in on what value is it approaching from the left, again, it's asking what y value is it approaching. So as x gets closer to 3, y gets closer to -4. That's all a limit is. What y value is it approaching? And sometimes you did this in algebra, I believe, but you just do like arrows. Like as x goes to 3, y goes to something. But limits are the real math notation behind that. Okay, we could also do the limit as x approaches 3 from the right. So the only difference is you pick a number slightly bigger than 3 and then head back towards 3. So as x gets closer to 3 from the right side, the y value gets close to -4. And because it's approaching the same thing on the left and the right, this limit, the real question for number 1 that doesn't say left or right, is -4. If your limit approaches the same number from the left and the right, then that is what your limit is equal to. So I'm making that fairly wordy there, but honestly that's about a 5-second question once you get the grasp of what it's asking here. So scroll down to question 2. What's a reasonable estimate for the limit as x approaches 5? Now it doesn't say from the left or the right, so we have to do both. Well, from the left, as x gets closer to 5, the y value gets closer to what? Okay, and then from the right, so you got to pick a number bigger than 5 and then head towards 5. As x gets closer to 5 from the right side, looks like the y value approaches -2. And then if it approaches the same thing from the left and the right, then that's what the limit is. Okay, you try question 3. Okay, and you should have come up with an answer of 2. As x approaches 0 from the left, it approaches a y value of 2. As x approaches 0 from the right, the y value approaches 2. And if it approaches the same thing on the left and the right, then that's what the limit is. Now again, this is the biggest misconception people have. The point either doesn't have to exist, or the point can be way down here. Limits do not care what's happening at that instant. Just what is it getting closer to from the left and from the right. So, same thing here. As x approaches -1, the point's way up here, but that has nothing to do with the limit question. You think about as x gets close to -1 from the left side, as x gets close to -1 from the right side. From both sides, it looks like it's approaching a y value of -3. So that's what your answer is. Okay, flip it over. So, same idea, but for some people, tables are just a little bit harder to read than a graph, but it's got to have the same idea. As x approaches -2 of g of x, so all of this is g of x, so we need to think about x approaches -2 from the left side, and as x approaches -2 from the right side, and it looks like these values are getting closer to something and these values are getting closer to something. What do you think this y value probably is in here? It's probably 8. That's why it says reasonable estimate. We don't know for sure that's what it's really going to, but it appears to be approaching 8 from the left side and 8 from the right side. So that's all the limit really is. What is the y value that it's approaching? Now again, sometimes you have the left and the right, but these are just saying what is that limit. So if it's not approaching the same thing from the left and the right, then we say that it does not exist because that doesn't make sense. Okay, why don't you try questions 6 and 7. So try this table 1 and try another graph 1. Okay, what'd you come up with as an answer on number 6?
-6.
Okay, I would agree with that. So, approaching 1 from the left is when the x values are smaller than 1, but getting closer to 1. Approaching 1 from the right is when the x values are bigger than 1 but getting closer to 1. And so again, this is just an estimate, but it appears that both of them are approaching -6. And if it's approaching -6 from the left and -6 from the right, then that limit exists and he is -6. Okay, somebody else, what about number 7? What'd you come up with on this one? What y value is the graph approaching as x approaches 4?
You have two answers.
You can't have two answers. So the reason why this is hard to say is because it's not approaching the same thing. It looks like from the left, the limit as x approaches 4 from the left would be 3. But the limit as x approaches 4 from the right is 6. So the limit as x approaches 4, the y value that y approaches as the y value it approaches as x approaches 4, it's not approaching the same thing. So this is what we would say does not exist. If it's not the same from the left and the right, we don't have two answers, it means we have no answers. It's not approaching anything consistently. Okay, and then one more time, go ahead and try the rest of these. I think it's just 3 more. Oh, I lied. 1, 2, 3, 4 more. Go ahead and try the last 4. We'll go over it. You can make corrections, but anything that you need to correct, I'm going to strongly suggest you add some words to it as a reminder to yourself. I think I had mentioned this last week, but for those of you that are moving on to calculus next year or someday, maybe you don't think you're doing calculus next year, but then 10 years down the road you change your major or go back to school or something, all calculus classes start off with limits. Calculus is really 3 big topics: limits, derivatives, and integration. Integration's the opposite of derivatives, and derivatives do not exist without limits. So you have to learn limits first before you can learn derivatives, before you can learn integrals. So, this is just to give you a touch of what some calculus is like. Now again, this is like the easiest version of these, but this is just the first introduction. But also meant to make that first couple weeks in calculus a little bit easier if you know some limits going into it. You guys already finished? Okay. Then let's check them off real quick. As x approaches 0, well, from the left it's approaching 5, and from the right it's approaching -5. So it's not approaching anything consistent. So we call that does not exist. Number 8 does not have a limit as x approaches 0. Question 9, as x approaches -4, looks like we've got the same problem. Again, this is the only part of the graph I care about. From the left, it approaches a y value of -3, but from the right, it approaches a y value of 2. They're not the same thing. The limit does not exist. Number 10, as x approaches -5, probably shouldn't have been so many of these in a row. But from the left, he gets close to a y value of 6, and from the right, he gets close to a y value of -4. but it didn't say left, it didn't say right, it just said what is the limit, so it's got to be the same from both directions. Another does not exist. And then finally, 11 is trying to get you to work it backwards. So as x approaches, what number would make it have a limit of 3? So I think there's a few different answers that would work here, but what is one that you think might work?
2.
Okay, I agree, 2. So if we look at x equals 2, he approaches 3 from the left and 3 from the right, so that works. Also, it looks like it has a y value of 3, I don't know, probably right here about 4.5. It's kind of a weird estimate, but technically there is another one there. And even right here, at about -8.5, any of those would be fine. All of those x values have a y value that approaches 3 from the left and the right. But as we work through limit questions and we work through ones where you don't have a graph, you don't have a function, it's always important to kind of keep in mind what you're finding when you're doing that work behind all that. So again, just a quick little introduction, but probably the most important thing here is if you can think of any of that you can summarize into a sentence or two, probably a good idea to write that at the top of this page so you could glance at it quickly and remember what a limit is and what has to happen for it to exist. But that is it for day 1 of limits. And you'll still have about 12-13 minutes here to yourself. So if you have something for another class to work on, that will be great. Oh, also, so you guys know, if you did not turn in an assignment, our late work policy is still the same as last semester, where you can still get half of the points or half of the points back if you didn't turn something in completed. But you do have to do it before the test. This little 3-day thing, law of sines, law of cosines, doesn't have a test, it's just a quiz. So if you got partial credit on an assignment, or if there was an assignment that you didn't do that you want more points for, you need to fully complete that and turn it in before class Wednesday. That would be the last chance. Since there's not a test that goes along with that, that you need to define the cutoff, and that would be what the cutoff is. do have those graded and in the grade book, but similar to last semester, you will have to wait until they are made up before you can see yours, so. If that's gonna bug you, then you may wanna hold off looking at it.